Good morning.
Yeah, hi everyone. Thanks for joining. So we can give some more amount of time to join others. Yeah, hi Srini. Good morning.
Morning, Gopi. How are you?
Yeah, doing good. Yeah, hi Srini. In my company, I have an opening for machine learning and as well as data science. Srini. Of course, if you are having any friends, kindly let me know. And also this Azure Databricks. So those kind of technologies are so required for our company. In my team,
Sure, definitely.
yeah,
So
I
data
think there
science
will
and Azure Databricks, is it?
data science and as well as Azure data engineering.
Data. Okay,
Yeah,
sure.
I think.
I,
Can you please go on mute in Phoenix? Yeah, thank you.
I just pass on to my students who are there and
Uh, Please come again, Srini.
no, I'll pass on to my students and
Yeah, sure.
refer them
Mm.
definitely. Sure.
Yeah, you can ask them to ping in my WhatsApp number,
Sure,
so
sure.
we can try to get them in.
No problem. Definitely, definitely.
Yeah, we can give another couple of minutes. We can start by 11:05. No, time is 11:03. We can start by 11:05.
Yeah, yeah.
Yeah, I think we can get started. Srini. Let them, others can join gradually.
Sure. Thank you so much, Gopi. And first of all, thanks for joining for today's demo, everyone. And my name is Srinivas, and I have totally near to like 20 years of IT experience. And I'm currently working as a Azure data architect in a multinational Japanese bank, which is in Singapore. And I come up with a combination of data engineering and data science as well. So, as per this particular Azure data engineering stack, I'm working since almost near to 7 years, and my core responsibilities are like building the data pipelines and maintaining them using the Azure data stack with Azure Databricks and Azure Data Factory Synapse and a little bit on Snowflake as well. I do also use Power BI for some other dashboard development, and my day starts with Azure data engineering stack and end with data engineering stack along with a little bit on PySpark as well. And as per the today's agenda, we are going to discuss about how data engineering is emerged and how Azure data engineering is specifically is unique in the market, and how a data engineer will use Azure to build the data pipelines at high level, what a data engineering pipeline will look like, and what are the important things which we need to focus more on to convert into a Azure data engineer, and how the job market is, and as of now, and I'll also explain about some of the basic important things related to Azure data engineering, and I'll also use some time for your questions and you can ask after that. And I think most of the people here have some fundamental knowledge of very, I'm not looking for like an expert, at least you know what is a database and all. Uh, Let me just share my screen. And when we talk about data engineering, if you want to see, a data engineering is a like a process that will help you to extract the data from different sources and then transform it and then load into the target, where this process will ensure that whatever the data you are extracting, that may be either from a single source, which can be a database, or from a multiple databases, or it can be also come from other sources in the market now. Nowadays, we go and see data. Earlier, people, when we talk about data, people used to talk about only data in the databases or flat files only. And people used to use only structured data, and they used to extract it, and then they used to do some kind of processing or transformation on that, and they used to bring that into a specific format, and they used to load into the target database. And the data which will be in the target here usually will be the golden source, which people call it as, and that was the a final data which the users will consume and leverage the data and get some benefit of it. And that is where the process people used to call it as ETL. So ETL was if you go and see in early 2000, between 1990 and 2000, there was a very a big revolution in the ETL space, where people were mainly focusing on bringing the data by using the tools like Informatica was there, where people used to leverage to perform the ETL, and the sources were mainly databases that time, and the source will be database, target will be database. Like my source will be Oracle, my target can be SQL Server, or my source can be SQL Server, my target can be MySQL, like that. So why this data engineering was important? Because whenever you want to go and centralize your data, enterprise level data, for example, I definitely need to go and have some process, because my data will be usually a raw data. It will not be anytime ready-made data, and I need to do some kind of processing on that level, call engineering, by using the data integration tools available in the market. There are many different integration tools available in the market. Like Informatica was there, and Data Stage. Later, when the big data came into picture, Talend and Pentaho also became very famous. All these tools, the final objective of all these tools is to extract data from multiple sources, transform them, and then load it to the target. The same ETL, if you go and see, as soon as in 1990 to 2000, the main focus was only to extract the data a little bit and only copy into the database. When I go and say from 2000 to 2010, the people were mainly focusing on ETL space, where they started focusing on how to centralize the data in a data warehouse. In 2010, what happened? The data suddenly got increased. There was a huge revolution in the data where big data came into picture. And why? Any can someone tell me if you know what is the reason for that? What is the main reason for high data growth after 2010? Anyone? I ask you. Any idea?
Yeah, maybe because of that social media, WhatsApp, Facebook.
Yeah, very good. Correct. Excellent. Because when you see in 2004 and 5, people were started using social media applications, especially in 5 and 6. We got Orkut and also slowly we got Facebook. When Facebook came into picture, other social media companies also got started, like LinkedIn started, and then WhatsApp, YouTube, and then we also got like Twitter, and then after that Instagram. So all these companies, their main motivation is to engage the people to use their applications. And when people started using these applications, ultimately what happens, everybody will have a mobile, everybody will have internet. They started uploading the images, videos, documents, all this stuff. And ultimately what happened, the data has, growth has been very, very high after 2010. Within a span of 2 years, there was a high data growth. Petabytes of data got generated by all these companies. And even when they started building this big data, there were tools also got famous, became like big data famous, became famous, like Hadoop. And slowly people started moving to ELT rather than ATL. ELT means people before big data was there, people used to extract, transform, and load. Whenever big data came into picture, people slowly moved to extract, load, and transform because they cannot transform the data which is in a high volume with high velocity with different varieties while they're extracting. So suddenly what happened? The ETL became ELT. So big data tools started helping the companies to centralize their data by extracting, and then people start using transforming them or processing them. So more data in the sense we can also use for the data for more analysis. Then data science also became very famous slowly. So most of the data science companies and data science projects also started after big data came into picture. And because data science projects, they majorly involve like videos and documents and images also nowadays. Because earlier people only they used to call database tables and plot files they used to call as data. Now even image also people are calling as data. If you go and see document also a data, and video also people are calling now data, because as a data engineer I should be having some knowledge on what kind of data available in the market, what kind of data we may need to sometime even need to process. It can be a video, it can be a document, and there are many new databases came to the market, right? MongoDB is one document-oriented database, Cassandra, HBase, many different databases also came into the market where companies started using them to understand their business and take appropriate better decisions to improve their business. Many companies like Walmart, example, when I worked with Walmart, they were majorly like especially for Procter and Gamble, for Walmart, to increase their business, they were looking to centralize their data into a big data environment specifically, and on top of it, they were ready to use data science as well to increase their supply chain process or optimize their supply chain process to predict the out of stock of PNG products in Walmart store. So that helped them to increase their business and also ahead in the market. So that other service providers, if at all they want to compete, they want to be ahead in the market. In advance, they want to predict their out of stock of their products. So that if any product will go out of stock, the customers will not switch to other service provider. So every company started thinking about this particular data science and big data after that. And also when you are performing this data engineering, the data quality also very, very important. That is one of the step where people will do the main cleaning activity to make the data available for the consumers with high quality. If you don't give the data quality, your analysis will be not correct. So you should do the proper data cleaning and data validation and data quality checks also after you do this data engineering. After you perform any ETL or ELT, you definitely need to do the data quality checks. That is one of the responsibility of any data engineer. So most of the data is will be unorganized, and we should be as a data engineer, we should organize it. That organize how to organize the data, we need to follow the strict process of either ETL or ELT. Both will help you to organize your data in a right approach and right format. And if you go and see normal traditional ETL process, most of the ETL process will involve, as I mentioned, all like company CRM and ERP specific data and plot files will be there, and database tables will be there. And then nowadays, as I mentioned, unstructured data also became the part of the ETL process. And then whenever if you go and want to perform this ETL, your data will be moved to a operational data store, which we call it as. A operational data store means a real time, we can say real time data warehouse. And then from there, we will go and use a staging environment to extract this data and push into a enterprise data warehouse. Again, in this enterprise data warehouse will be divided into individual data mart by department, and each department after this will go and leverage their specific data mart to generate or understand their department business. So it will be not only dashboard here. Sometimes nowadays people are even leveraging this data for some kind of data science activities as well, and data analysis activities, dashboard development, and many different users are leveraging this data. So the traditional ETL process now became very, very important, and where companies are focusing more in this particular area, because this particular business intelligence area will help the companies to understand their business and increase their revenue, and also ultimately they how they should be compete in the market. So dashboard development, now people are using many different tools. Power BI is there, Tableau, ClickView. So but all to build dashboards, we need data. That is the responsibility of a data engineer only. A data engineer is the person who will provide the data to the users in the company. There can be machine learning engineers or data scientists, or it can be dashboard developers, data analysts. Everybody will depend upon data engineers. So data engineers is the key person now. Every company is investing more on data engineering. Assume that I have some healthcare specific data. If you go and see any healthcare company, they will have data will come from different sources, public records, and then patient portals where they will go and capture the patient information, and there will be some wearable devices where they will capture the health condition of the patients, and electronic health records where they will even capture the daily information of the company, and pharmacy information they will capture, and clinics information, laboratories where they will also generate some kind of digital images and for scanning reports. See, all these are part of every company's data. You see, every department will have their own application, and they will capture their data in different formats. So maybe the patient information, the application is they will capture in CSV. Pharmacy can be XML format, and the labs can be JSON. Clinic will be again Excel. Research information can be in CSV. So these are all different formats. But how can we go and integrate them? How can I go and bring them into one centralized location? So sometimes there will be digital images and scanning reports and images. How to bring them? How can we integrate all this? And how can we go and centralize that? That is where the responsibility of data engineer will come into picture. So either ETL or ELT, anything. A data engineer is responsible for integrating all these and then bring them, transform them, and load into the target, and then that will be utilized by the company's business analysis. And the main important reason which I was talking about also, when Facebook started in 2004 and YouTube and followed by other social media companies, all these generated huge amount of data. And when you go and see now in 2024, you can imagine how much amount of data is they are generating. So every day you can see petabytes to zettabytes of data these companies are generating due to because of their Facebook with their uh, members, they will post so many messages, documents, and videos. And YouTube also, you can see daily how many videos people will go and upload. And Twitter, WhatsApp is another source now. Everybody is using WhatsApp, and Instagram is also become a daily like people are using Instagram, and they are also you can see like so much amount of data is generated. All these companies like they are main reason for fact why the data has been growing, and why we need to also think about how to manage this particular data related to our company as well. And as I mentioned, internet users, smartphones, sensors, and smart devices, IoT devices, all these are the reason for the big data. That's what the conclusion. And the data is also very important to the company. Why? Because it is very important for decision making. Maybe based on maybe my last month sales and current month sales, I can compare and I can see what is the data sales growth, whether whether it is an increase or decrease, and what are my assume I am running a store group of stores, and I want to compare each store sales and how each store is performing, and what is the store that is not that is underperforming, and what is the reasons behind that, and what are the actions to be taken to increase the sales of that particular location, and what are the factors impacting the reduction in sales. You need to understand and analyze that, and to also the organizations can go and understand the customer. If they have the customer data, they can go and understand the customer, right? For example, you go and see in Amazon, you might have experienced whenever you buy any product, and before you are going to pay the money, you will get some recommendations. And when every customer will get some recommendations before they are going to pay the money for the products in the cart. Why? Because Amazon will try to understand your behavior. They will try to see what are the activities you are performing in their website, which products you selected, and which pages you visited. They do track everything. As a customer, whatever you do in their website, every company will track. Why? Because to get the right information for their business, and to understand their customer needs, and how to optimize their systems and processes, they need data. Because if you don't have customer data, I can't understand what my customer is looking for and what is my customer interest. So they do all this data physically. They do collect the data, they do the analyze the data, and then that will help them to increase their revenue and ultimately improve their business value. in the market. And sometimes people also look for what are with some feedback, like management, whether the customer is interested or not interested in their products, and what is the reason for that. People will even will go and track that. So every company will do that to understand where they are standing in the market. And data cleaning is one of the process which we need to understand, where you need to go and see how to go and do the cleaning. So for example, if you see the gender column, the name is good, but the gender column is not correct. You can see somewhere it is male, somewhere MA and M. For female, it is FEM, F and then we can see like female and FE also. So we need to standardize this. We need to standardize this like this with single format. This is one of the data cleaning step. And one more thing is like age. If you see here, name is correct again. Age is not in single format. Somewhere it is in years, somewhere it is in months, and somewhere it is in like decimal point, which is not correct. So we need to go somewhere it is date. You need to convert into a single format. So this is one of the process every data engineer should do. How to go and bring the data, how to perform some transformations, and bring the data on the format which I am looking for. Every data engineer will work on this particular transformation, where they will bring the data into a desired format, so that will be utilized by the consumers. And coming to the data devices which are generating this data, you can see many devices are generating the data, and where you will see like most of the data is coming from different sources here, like government sectors. You will see like in medical sector, internet, retail companies, financial sectors, most of the phone and TV, mobile and TV, where we are getting the more data is generated. And there are companies who will collect this data, and they do aggregate, and they will also sell the data. There are companies like Nelson, for example. Also, you'll see like Morningstar, WorldSec. After big data came into picture, these companies also become very famous because they collect the data. They do data business. They will go and bring this data and aggregate and do the ETL or ELT on that and centralize, and they will sell the data. You can see most of the companies nowadays buying the data, because even credit card companies and investment companies, telecom companies, they do will go and buy the data, because they don't want to go and centralize the data. They will depend on these companies. So as soon as data has been increased, data companies also increased. Their business also increased. Every company who will involve in this data collection, they became very famous now. Nelson is one of the very bigger company. They will use the universal data. They'll collect. Someone asked me something. Can you hear me now? Amit? Can you guys hear me? Everyone.
Yes, sir, you're audible.
Okay. Because Amit is saying I lost my voice, so that's why I'm asking. Okay. So when I talk about this data companies, their business is to collect the data, and this data will be utilized for other companies' growth. Telecom companies, they use, for example, Airtel, they will buy the data from these particular companies. They will not go and build their own databases or data like warehouses. They do buy this data, and they will use this data for their business growth. They will reach out the customer, and they'll provide their products. They will offer their products, and credit card companies, they offer their credit cards. These are all very, very common to go and see in most of the market. Just a minute. Just 1 minute. Just 1 minute.
Yeah, sure, Srini.
So sorry for that. So when I talk about data collection, these are the companies who are performing the data collection. And the drivers of big data also we discussed about medical information, where medical companies are capturing, and photos and videos which are uploaded to internet. And video surveillance companies also generating huge amount of data, where they will go and collect so many videos. And example, like criminal departments, they will capture the videos and they will tag suspicious people also. So that also one of the important area where data has been grown. And mobile devices and smart devices also nowadays generating data. If you go and see other countries, even in India also, you can find some smart electric meters which will go and generate some data. And non-traditional IT devices like credit card readers, they will generate the data. And most of the data, as I mentioned, will be in general these four formats. Structured data. So structured data, semi-structured, quasi-structured, and unstructured. These four formats are mainly important for data engineer. As a data engineer, I should know if someone come and ask you, you need to work on quasi-structured, and you should not be blank. You should be able to understand that what we need to do. Structured data means, as I mentioned, RDBMS, where we can go and connect to any database or pull some flat files or Excel files. These are all fall under structured data. And second is semi-structured. Nowadays, after big data came into picture, you can find many different formats came into picture, like XML, JSON. You'll also find like Parquet, Avro, ORC also part of this particular data type. And third one is quasi-structured. When you are, as I mentioned earlier, whenever you go and visit any website like Amazon or any website, they will track your activities in their website using the quasi-structured format, which is called clickstream data. So as a data engineer, I should know how to process this quasi-structured data too. And finally, unstructured data, which is, as I mentioned, PDFs, images, documents, also like we can also call voice also as data now, where people are trying to analyze voice conversion, voice to text conversion, voice comparison. Google Assistant is an example. So most of these are different types of data where a data engineer has to focus more. Every day, the data may grow. For a company nowadays, 2 terabytes is not a big data. Within a day also, people are generating different amount of data. So data is growing. Data is growing, and when data growing means, as a data engineer, I should also think about how to manage the data, even it is huge. Big data. Big data engineers are very famous now, because normal data, like in database and all, maybe in maybe 1 terabyte is very, very huge. But if you come and see in big data, your data will be in petabytes to zettabytes. As a data engineer, I should be able to manage even huge volume with high velocity, plus also different varieties. All these are very, very important. If now we go and see, the data might have already reached out to yottabytes, because it was in petabytes. Now definitely it reached into yottabytes, because you can imagine how much data daily the industry is generating now. And drivers of big data also we just now discussed about. Oracle was in 90s, which was generating majorly like in like terabytes. Slowly we moved to like petabytes in the 2000s, because of a digital management like system like MS Office and Acrobat Reader. And in 2010 onwards, there is a huge revolution because of all this social media. And data growth also, now it is moving to zettabytes. Definitely it will reach yottabytes going forward, and you should be ready to manage like zettabytes to yottabytes going forward. And to manage the data also, it's very important, because data will keep on increasing. I cannot go and manage it if I properly plan it in advance. So for example, whatever you can see in this example, if you don't properly manage this rainwater, what will happen? It will go, and you can see how every house, the entire water will enter the house, and normal life will be affected. and water will spread across the streets, and you should know how to properly manage and storage the water also. Example, similar to that, data also should be properly managed. If you don't know how to manage it, it will go and affect the entire company's business, and you should know how to properly manage that particular data. And so data means now you need to think about volume, velocity, and also variety and veracity as well. How trustworthy the data is, that also important. Not only volume, size of the data important, and how fast you are generating the data or processing. Plus, you also need to see how different varieties of data available, how can we manage it. Plus, the data which I am generating, is it trustworthy? Can I rely on this data for my analysis? That also important. Okay, that is where you need to go and focus more on how to perform the proper data validations to make the data trustworthy. Okay, so data come from different sources, if you see, and then centralize it and utilize it for your analysis. And traditional tools, if you see in the market, as I mentioned, we have many different tools. Talent, I was mentioning. Talent is one of the big data integration tool. Microsoft SQL Server, integrated services, business objects is there, and Informatica, SAS, data integration. All these tools will help you to integrate your data in the ETL space. ETL space in the sense extract, transform, and load, majorly on the structure side. And there are some challenges when you go and see to maintain this particular tools or data in the on-premise, like in the physical server side. Why? Because it will increase your maintenance cost, right? If at all I want to maintain a Oracle database environment, I definitely need to maintain that by having a dedicated Oracle database team. Need to hire a DBA and then also developers, and I need to have a dedicated team to maintain it. And also investment is important, upfront investment. And also I should also maintain some like backup if there will be any disaster will happen. Not every company will be affordable to maintain that much amount of data and buy the license, all this stuff. Need to also follow the industry compliance and required extra IT support, and that's where would be some performance hits also will be there when you are maintaining. You also need to be ready to maintain that. Every day it may not be a good day. You need to go and ready for how to resolve the issues which you will experience with performance perspective. Every day the database may not work like how it is going to work earlier. Some days it will be data mesh may suddenly it will go down, and you need to find out what the reason for that, and how to write or optimize your database SQL queries so that they will run fast. They will not run for longer hours. You need to also have that particular expertise to maintain it. And if I ask you as a data engineer to convert into a big data engineer, these many tools you need to learn in after 2010 and in between 2010 to 15 to 16. Even when I moved to big data, I learned almost all these tools, because to maintain a big data warehouse, definitely people should know all these tools. If I ask you guys to learn, definitely nobody will be, right? So because these many tools, one person, if you ask him to learn these many tools, they will definitely will be hesitate to learn because not easy. But that is the fact. People has to learn these many tools. In early 2010, if you see, most of the companies, when they migrated to big data, so many frameworks came to the market, like Apache, like MapReduce and HDFS were the frameworks which they started first. After that, we have many other frameworks like HBase for database storage, and then Hive to maintain the data warehouse in big data, and then MapReduce for processing, and Kafka for real-time streaming, and also like Uzi for scheduling, and Zookeeper to like maintain the or perform the orchestration. Many different frameworks came to the market. If you go and see, some of the frameworks are not even available now. So why? Because every day you will get a new framework. We cannot go and learn keep on learning new framework every day. So that is the challenge with big data ecosystem. Every day you will get new framework and you cannot go and learn every day. So challenges for not only developers, there are challenges for companies also to maintain this big data system, because big data ecosystem is fragile. Maintenance is hard. Every day you need to do patching, upgrading, which is not even easy. You should have a dedicated team to do that. You should have a Hadoop administrators who can manage this. Performance also requires manual intervention. And one more biggest challenge is to find a technical resource who knows all this. Correct, right? When I was learning, I struggled a lot to learn. I know most of the tools available in this slide except one or two. So learning curve will be very, very big here. And integrating also very, very big challenge, because every framework will be independent here. To integrate them also, sometimes you will experience so many like errors in between, and you should be ready to resolve them. And every error will be in Java. That is also a challenge. Everybody may not know Java. Who knows Java, they can understand very easily. The error is in Java. Sometimes it will be difficult to debug it. And finding this technical resource who are like having this knowledge is difficult. And managing the Hadoop cluster, which is open source, is also difficult, because you cannot get like people who can manage these Hadoop clusters easily, and we cannot reuse the existing people who are already in data warehouse, and like reuse them for big data also not easy, because everybody may not be interested, right? If I ask someone to, you should tomorrow onwards, you should start learning all these tools and you need to work as a big data engineer, means you will definitely not be ready, because everybody may not be interested, because learning curve is there. And that too, one tool or two tools, that's fine. But if you ask them to learn these many tools, they will say, I will work on the same technology. That's what the answer will receive. And a rare resource means even they will demand high salary. These are all the challenges to maintain a big data. So the company started thinking about, so how can we do that? How can we go and manage this big data? On-premise is giving us so much, like so many challenges, not only with uh, I can say investment side. The investment not only with money, it is with like workforce also, and maintenance also. How to go and manage this? That is where the cloud computing came into picture. When I talk about cloud computing, which is a cost-effective, unlimited storage space, that is also important. See, if I go and want to maintain my own big data environment, I need to buy storage also. I need to buy like the servers, and I need to have a backup and recovery management. Efficiency is important, flexibility, and we need to have a faster deployment methods. All these are very big challenges in like on-premise physical servers. These are all the benefits of a cloud computing. Cloud computing can help you to go with a pay as you go, pay for what you are going to use, and they'll provide unlimited storage space. They'll do automatic backup and recovery. We do not need to do, and all the cloud services in the market are efficient, flexible. I can do instant server. I can go and create, and I can keep on adding to my cluster. So that is how cloud is helping, and everything is like you cannot go and plan upfront. And when I was working for a big data project, I used to be part of all my infrastructure meetings, because I also need to decide what infrastructure required for my project. Then we used to buy infrastructure for 1 year in advance, and which used to even wasted sometimes. Only sometimes I remember that we were not even used to use not even 50% of our infrastructure which we bought. So there are so many challenges. So that is upfront, like planning and all not required if you go with cloud computing. And most of the cloud computing will help you to access your resource from anywhere by using any device 24/7. That is the main core benefit of this cloud computing, why companies are slowly moving. And after, if I talk about cloud computing, most of the resources you see here, everything will be in cloud. Your servers will be in cloud, your virtual desktops will be in cloud, and softwares will be in cloud, applications will run in the deployed in the cloud, and the storage also will in the cloud. Everything if it is in the cloud, and you just need a internet connection to access all this from any devices, that and 24/7. That is the main core benefit with cloud computing, why companies are moving. And plus also need to think about when I need to manage all these things like storage, server, security, infra team, I definitely need to compare with how it will be cost for me in the like on premise, and how it will be going to reduce if I use cloud. So cloud will be the one of the right solution for maintaining all these in one single location. So challenges which if we talk about with on-premises, high setup cost is required to launch, and more resources also required if we will go and move forward. So these are all challenges. And cloud computing will, as I mentioned at high level, for on-premise, I need high upfront cost setup, and for cloud, pay-as-you-go model, no upfront cost. So no automatic updates will happen. We need to do some kind of manual updates, but cloud, you have automatic software updates. You go and see either Azure or AWS or GCP, definitely the software updates will be done by the team, Azure team or AWS team or GCP team. We do not need to worry about for any service. But in case of my own on-premise data center, I definitely need to do that on my own. My team has to do that. There is no flexibility to even upgrade in on-premise data center. You need to down all the machines. But in case of cloud, you will have flexibility to upgrade anytime. That too with a few clicks, where you can go to the portal, web portal, and we can do that. And you need to appoint a dedicated staff to your data center, right? If you go to physical data center, they need to physically present, and they need to go and maintain it if any issues will arise. But in case of cloud, you do not require any staff to maintain it, because the cloud team itself will take care of maintaining the data center. And the data cannot be accessed from remote if I go with physical on-premise data centers. I definitely need to be present like at that location. But in case of cloud, data can be accessed remotely over the internet using the web portal from anywhere, using any device, anytime. That is the one of the main advantage with the cloud services. And in that, these are the cloud services available: AWS, Azure, and then we also have Google Cloud and IBM Cloud. You might have heard about Alibaba Cloud and Oracle Cloud, and also, but most of the market is captured by Azure, AWS, and GCP. And these are the topmost service providers, cloud service providers in the market. Among that, Azure and AWS are on the top, and then followed by GCP. And what is Azure Cloud? Azure is a cloud computing service created by Microsoft, where users can create their own servers, storage systems, databases, etc., using online web portal which Microsoft is providing. And your data centers, physical infrastructure, everything will be maintained in the online portal only, web portal we call it as. Azure also same, they also will do the same. GCP also the same, but everything will be in the web portal, where you will need to create a account, register to account with the ID and password you create, and then you log in and use it. So that is how Azure will help us. And if you go and see, okay, Azure, you can for Azure cloud computing, we can create an account, and we can just take a Gmail account, we can create, and we can create a username and password, we can log in. And how it is going to help in general in data engineering space. So if you go and see, there are different services available in Azure side. ADF, Azure Data Factory. In general, in on-premise, you need to use some tools like Informatica to perform this data ingestion. And in big data side also, you have different services or like frameworks available. Apache Scoop, which I can use to extract the data from databases to big data environment. And I need to use like for structured data, I need to use like a Scoop. For example, any like unstructured data, again, I need to depend upon some other framework. Real-time streaming data, I need to depend upon Kafka. So for scheduling, I need to use OZ. For any data warehousing kind of SQL kind of queries I need to run, I need to depend upon Hive. So there are different frameworks involved to achieve all this. But for the data ingestion space, I can use Azure Data Factory is one of the service that will help you to ingest your data from different sources from the on-premise, and which can be directly pushed into another service called Azure Data Lake. Generation 2 is where you can store the data, and data also, right? Whenever you ingest the data and push into this Azure environment like Azure Data Lake store, all this, your data should be divided into different layers here. Why we need to do this particular categories? Because whenever you load the data, that will be as it is, raw data will be there, and from the raw data, which we call it as a branch layer or branch zone, we'll try to do some transformation on the data, right? Raw data. And when you are performing the transformation, and then we are performing like any kind of transformation, you need a intermediate storage, and we'll push into some intermediate storage called silver layer. The silver layer is the layer where you will process the data. The bronze layer data will be processed in the silver layer. From the silver layer, we'll push it to gold layer after the processing is completed, which is all done by the service Azure Databricks on particular bronze layer and silver layer, and it will generate the data in the gold layer by applying some transformations. Here we also use PySpark for the transformations here. So PySpark is one of the framework which is very famous in Databricks side where people use, and we'll use PySpark to do the transformations on this data as soon as we ingest the data using ADF. And once after my data is available in this particular gold layer, we'll try to use Azure Synapse Analytics. Basically, this service is designed for maintaining your data and perform some kind of analytics. Also, we can call it as a data warehouse. Load the data into Synapse, and once after my data is available in the data warehouse, we'll do data ingestion with ADF, and we perform transformations like Azure Databricks transformations. Finally, push into the Azure Synapse Analytics to maintain it. As soon as my data available here, we can connect with any reporting tool here. Here we are talking about Power BI. You can even connect with other reporting tools like Tableau, for example, ClickView. Many different tools available in the market where you can go and perform your data dashboard development. And the security and governance, anyway, Azure is providing by on its own. We do not need to go and maintain any security. But big data side, if at all you want to maintain in on-premise, you need to use separate softwares. How to authenticate securely for the enterprise level, how to go and integrate with a single sign-on SSO, how to integrate with like LDAP, and also how to maintain the data. What is the data governance policies we need to follow? Many things we need to decide if you go to on-premise. But here, Azure itself, they are providing all this while you are maintaining your data. So everything is integrated in one single portal. We just need to log in and use it. That is the main core benefit with the Azure environment. And this is the single example of architecture of any data pipeline architecture where you go and see in data engineering of Azure. You'll see all these services like ADF, also called as Azure Data Factory for data ingestion and Databricks for transformation, and a Synapse for data loading and maintaining in a warehouse. And from there, most of the companies, they are using Power BI. Because why they are using Power BI is Power BI also a Microsoft product, so where they can easily integrate with this Azure Synapse and other tools. That is the reason companies are even preferring Power BI here, where we are also going to learn Power BI as part of this training, how to integrate with Azure environment. And Azure is, if you go and see most of the Azure investment, they start investing 1 billion investment per year they are doing now, even only on cyber threats, and they are investing on like even data science and AI space also. So this is one of the fastest growing cloud service and second largest market after AWS, and slowly it is even capturing AWS market too. If you go and see in Europe side, none of the companies use AWS. They always use, every company will use Azure only. Only US market you can see most of the companies are using AWS, but many companies in Europe side, 80 to 90% they use Azure only, to be honest. So here Azure is capturing the market slowly, and one of the cloud service provider which is also allowing us to create the data pipelines and data engineering activities. So it is better to even learn Azure and switch your career is very important. And how can I start it? I can start with a free account where later I can convert it into a pay as you go account. So it is not difficult. We can simply create a Azure account by log into the portal, and I'll show you how to create all this once you move into the training and all. It's not that much difficult because it's very easy. Within 5-10 minutes you can create it, and we can go and start using it in the Azure portal. Now let us try to see how this portal looks like. The Azure portal will look like this, and you will see multiple different services will be there. SQL databases where that will help you to maintain your databases in Azure cloud environment, and Azure machine learning basically designed for performing machine learning activities in Azure side, and virtual machines will help you to create any virtual servers in Azure environment. I want to create a Linux server or I want to create a Windows server. I can use this particular virtual machine. Okay, so if you go and see like the roadmap, what we have to learn is Azure data engineering. Majorly, SQL is one of the fundamental like technology required for any data engineering or data science, whatever it is. So SQL is one of the first like language which you need to learn, and Python is another language which is important because when you are working in PySpark, Python is important. So we are going to learn Python as well, and data warehousing fundamentals, if you know, that will also help you a lot, but we are going to cover anyway. And big data and Hadoop as well as Spark is very important for, because to perform the transformations and all, we are going to use PySpark. So we will learn PySpark as part of this training to maintain our transformations in the data pipeline. We use PySpark here to manage the Databricks environment. We are going to use Databricks here. So we need to know how to manage it using PySpark. And the cloud computing, anyway, we are going to use all these Azure fundamental services. Along with that, we are also going to learn about ADF for data ingestion, and then Azure Synapse for data warehousing, plus a bit on Power BI as well. So we are going to learn SQL, Python, and then PySpark, and then Azure Data Factory, Azure Databricks, plus Azure Synapse. All these services are very important for any Azure data engineer. You can even go and check in the any JD. All these are common. And Power BI is not mandatory because there will be Power BI developers. But if you know a bit on Power BI integration with Azure, that also will a plus. And the demand for data engineers, we go and see, it is keep on increasing. Most of the market, if we see in 2022 to 23, there was only 10% to 15% requirement, and 24-25 it is increased a little bit, 20 to 30%. Now if you go and see in upcoming years, definitely it is going to increase 50 to 60%. And you can see most of the data engineering, if you go and search even in data engineering in either Naukri or LinkedIn, you will find more jobs on Azure side only. If you go and see, for example, in UK, you can even check in UK LinkedIn, you will find more data engineering jobs on Azure side. So most of the like companies, they're slowly increasing their data engineering stack in Azure side, and even people who are in AWS also slowly migrate to Azure, because they're experiencing a cost reduction in Azure when compared to AWS. And opportunities also, like different domains, you can see banking. I am working for a bank, Japanese bank. I am using Azure since almost near to 7 years. All my projects involve like Azure data stack and Azure basic services, PySpark, SQL, everything. And e-commerce companies, Amazon kind of e-commerce companies also using this particular data engineering, specifically on Azure side, and telecom companies, healthcare companies. You can also find travel domain. So travel domain also they are using data engineering to maintain their passengers data, for example. And retail companies like Walmart, as I mentioned, their supply chain optimization, and they definitely need target is another company competitor to like Walmart. There are many different companies are there in supply chain and retail side. And the digitalization is also companies are slowly migrating. Whenever my company, when they started digitalization, they slowly started using this Azure cloud, and now our whole digitalization is on Azure cloud only. Okay. And the salaries also, you can imagine how the pay is like companies are paying very like high salaries for Azure data engineers, because if you know this many tools, definitely the salaries also definitely will be high. And most of the companies minimum for like based on experience, you can find the like decent salaries for Azure data engineers compared to other data engineers. We have other data engineers also in the market like Snowflake data engineers, AWS data engineers, GCP. We can also find Python specific data engineers also. But comparatively, the pay is almost equivalent. But Azure, you can find a little bit higher because there are high like like data stack is there in Azure side. And median salary for data analyst is per annum. As per my observation, uh, I observed that there is 17 lakhs minimum is there, and with highest salary, I can even show you 60 lakhs per annum also. That's, there are people, there are people. To be open, even I am also getting nearby that. So the based on the experience also it is important, I can say, but your experience is a little bit like decent, and you are earning a decent salary, you can look for a good hike as well. And because it's one of the hardest skill in the market, no people are there. Even people who are already learning, they are not 100% learning with effort, I can say, because most of the people like I do interviews for my company and some other freelancing interviews also I do. And I go for interviews also, I see people who are coming for this particular Azure data engineer positions. I see that people are they don't focus more on the process project side. They come up, they know what is the tool, but they don't know how to connect the dots, how to integrate the services, how to go, and they might have not even worked on any project also. That is the problem. You need to go and work on an end-to-end project, at least one or two projects, and with different services. Then only you can go and justify yourself in the interview. So I advise the people, my students, that at least do two or three projects end to end and try to understand what is the purpose of the tool and how you can utilize if you go to any company. That definitely will help to understand and justify ourselves in the interview, and can be confident also. And banking is the highest share of data in it, 37%, which you can see among all the like all non-IT sectors and all. And you can also see 30%, 30 to 30.8%. You can see the data analyst having experience near to 2 to 8 years. That's what all my observations. And who should go for this course? Some of the common questions which I get, like there are some good opportunities for freshers also, and where you can go and optimize your skills, like you can optimize your analysis skills, like how to do the data analysis, and also how to utilize big data along with PySpark. How can I go and optimize and I can use this particular tools, and how can I go and change my career? That is also important for anyone. Career switch towards high paying skills also, some people will be motivated. I know that. Even I did all my career when I switched from database developer to I moved to like ETL, and ETL to big data, and then big data to data science. I worked for some time, and then from data science I slowly moved to cloud, that too specifically Azure cloud. And I also work on Snowflake, but majorly on Azure cloud only. But every time I looked for a learning curve, career growth, plus pay scale increase also, because I cannot go and like work for the same salary, right? So ultimately I look for all these aspects. And even non-technical people, some people will ask me, can I go and switch over? Definitely. See, the tool, this is not like a specifically technology side. I can even say, if I go and ask you to learn Java or C or C++, definitely you need to think about, like, Python is one of the easiest language to learn in the market compared to Java, C, C++. And PySpark is integrated with Python. So if you learn Python, PySpark will be easy. And most of these tools are plug and play. So learning is very easy. Learning curve also will be easy for the people who are even non-technical people. And high demand, high pay. So that is what the main common questions which I receive from the people. And as per this particular training, we are going to cover most of the commonly and regularly used to services, even what I am using in my project, and I'm going to teach you about that. And what are my real-time scenarios which I experienced and I resolved, and the projects which I worked on. I'm going to experience share my experience, and you'll get all the specific uh, knowledge about the real-time environment of Azure data engineering, and how to build the ETL pipelines for various business domains. We'll learn, and we'll also go learn about majorly the cloud services here, all cloud services. And these are all the tools which I talk about. Like in Azure side, we will learn about ADF, Databricks, and then data uh, Synapse Analytics, all these three along with PySpark. And all we learn with real-time projects, and we are going to create 8 to 10 data pipelines. And I'll also provide some resume preparation assistance, and you'll have the training will go. We are planning for 70 to 80 hours, but we'll plan accordingly. And all will be with live examples. And that's about uh, the Azure data engineering at high level introduction, and how the market is, and what we are going to cover and all. Now for your time to ask questions. Anyone? You can start.
Yeah, thank you, Srini. So you guys can ask the questions now, like any kind of questions which are related to Azure Databricks, data warehousing, any databases, like that. You can ask any kind of questions.
When it is basic, you can ask. It
Yeah,
doesn't mean that it is you are already working, or you already know Azure data engineering or data engineering, whatever it is. If you are not sure about anything, please try to ask here and try to resolve it here. I can try to help you. No questions?
Yeah, hi, I'm Nagaraju.
Nagaraju, please go ahead.
Yeah, yeah. So this course we are covering along with Python and PySpark a combination, or only Python oriented?
No, Python
I
and
mean,
PySpark. That's what I mentioned. If you see here, I'm
mm,
specifically mentioned PySpark only. You can see here.
okay,
So Python is a base for PySpark, right? We are going to learn Python before jumping into PySpark. So because if you don't know Python, you cannot
mm,
understand PySpark, right?
okay.
So because the
Yeah, yeah, correct.
integration of Spark and Python. So PySpark is very important here for Databricks. So we are going to learn PySpark, and before that we learn Python only. We'll cover both.
Okay, okay, fine. Yeah, okay.
and one more thing, Python is a very easy to learn. So
Okay. True.
whatever information you are getting in WhatsApp, right? So this that code I have
Yeah.
only built, so it's automated message.
Okay, okay, okay.
So I was using Python code and I have tried it, but it was executed very well.
Oh,
Just to
okay,
prove.
okay.
Yeah,
Thank you, thank
Python is
you.
a versatile language. You can do anything, huh?
Really, really, really.
Yeah, you can do website development. I can do data science. I can build a chatbot. I can do many things.
And I am also, yeah, I'm more than 15 years of experience in this data industry only. I have switched my career from Oracle to Snowflake and as well as ADF. So this is what my tech stack. So we are ready to here to help you to prepare a resume and the job guidance as much as possible. Usually, most of the centers they won't give 70 to 80 hours of training. Here, what we are stretching the timing to give more information to the candidate. At least, I mean, whatever fees they are paying, we try to give as much as possible information to secure a proper superb job with a high pay. That's what our motto. You can
Yeah,
ask your
that's really good.
questions.
That's really good to know. And you're providing the videos also, right? Access because sometimes may not be attending the class. Sometimes so if you refer
You will
the
get
video.
recordings. You will have a Google Drive where you are going to place, and you will get all the access to the materials, recordings, and hands-on scripts, and also assignments which you need to work on. You will get access to everything.
Yes.
Okay, thank you.
No problem. Any other questions from anyone? Bhuvana, Piyush, Aditya, and Priya.
No, from my side, sir. I'm
Okay.
good.
I'm not sure who is this Samsung SM. May I know who is this? Do you have any specific questions? There is one person with joined with Samsung SM.
Okay. Fine.
Okay, then if you don't have any specific questions, then we can wind up and
I think we got some queries from the chat also.
okay, let us see. Who is that? Let me see that. Pavani. Pavani, it is we are planning for near to like 2 months now, and so mainly because we are covering most of the tools here, and also including projects and all, and coding is with Python language used. We are learning with the you can learn it because see Python is one of the languages required here because some of the transformations which we do definitely you need to do with the PySpark. So we are going to learn Python, but that is the easiest language to learn. For you to answer. Yes.
And one more thing, when they are asking about the coding, right? Actually, this Azure Data Factory (ADF) is a no-code ETL tool. So without using any code, you can do that. Python is used only for Databricks, PySpark, and Python. So it's there is no other way we go. If you want to get into some better career means, not only this one, we have to learn like Srini told, we have to learn Power BI films also. We have to learn as much as possible. So whenever we are going to the interview, we have to explain how this tool we are going to utilize in this project, how we have used, and how we plan to use. So that much of information we can provide.
And this is
Yeah,
one of the
Pavani,
hottest, and this is one of the hottest technology also in the market. We don't see.
correct, exactly. Most of the people are getting into this. Even I am also moved from AWS to Azure.
Okay. Yeah. No. To be honest, right? So
Yeah,
definitely companies are who are dealing with the data and all. They are looking for even especially banks are looking for this particular Azure stack only. No more questions.
yeah. I think, suppose if you have any questions, you have my number. You can feel free to ping me. We can discuss about this course and all everything.
Yeah. So
Okay,
Gopi
sir.
can help you. Gopi can help you on like any specific questions related to like course details and timings and fee, everything. You can reach out Gopi. Gopi is the right person for that. Okay.
Yeah. Thank you, Sunny.
No problem.
Thanks
No
for
problem.
joining
Yeah.
again.
Yeah.
Thank you so much.
Yeah. Thank you for joining everyone. Have a great day.
Yeah. Have a good day. Bye.